Okay, I'm going ahead and recording a part of office hours where I was going to answer a question that was emailed to me. So this is in the 8.2 homework where you're given kind of a messy equation that we can infer as the equation of a hyperbola and asked to write it in standard form, graph it, and identify the vertices. So starting with putting this equation in standard form. So standard form for the equation of a hyperbola it can have two forms. It can look like this. So you can have something like x minus h squared over a squared minus y minus k squared over b squared equals 1. This will be a hyperbola with center at hk. And with the x term positive, so the x expression is positive here, notice, and the y expression is negative. When the x expression is positive, that means that your hyperbola is going to be oriented horizontally, so something like this, when the equation has that form. That's as opposed to if this has the form y minus k squared over a squared minus x minus h squared over b squared. So if the y expression is positive, then it will be oriented vertically, something like this. So that's the first thing to notice. Okay, so when the x term is positive, it's oriented horizontally. Y expression is positive, it's oriented vertically. And here we can kind of see at the outset, because the y squared is positive here and the x squared is negative, this is going to be a vertically oriented hyperbola. The final graph is going to look something like this. Okay, but as far as getting it in standard form, and so the standard form actually is going to look more like this than like the one up at the top. We want to make it look like that. And the way to do that is to complete the square, but one step at a time. So I'm going to start by collecting the y terms in one parentheses. So I'll collect 9y squared. What else do we have? 54y in one parentheses, and then group the x terms in another parentheses. And I'm going to go ahead and pull out the negative. So minus 16x squared here and minus 160x here, but I'm factoring out the negative right now. So I'm going to write this as, this will be plus 160x, because I want it to be consistent with what I started with, which is negative 160x. So if I'm going to put a minus out in front of this parentheses, then I need to change the sign inside. That way, this is still, if you imagine distributing the negative, this is still equivalent to negative 160x. Okay. One other thing I'm going to do is send this constant term to the other side. So this is equal to positive 463. What I did to do that is add 463 to both sides here. Okay, so we get this equation. I know it's a bit messy. I'll try to get nicer handwriting from this point on. All right, but again, we're trying to make it look like this here. That's the standard form we're shooting for. What we should do now is factor out. So notice that it's just y squared for your leading term here and just x squared for your leading term here. So if you have a coefficient on the squared term like the 9 here, you need to factor that out. So if I factor out 9, that'll leave me with y squared minus 6y. And I'm going to leave a little blank here for completing the square. I'm going to do that in a minute. Same story here. So I need just x squared, 1x squared. 1 needs to be the leading coefficient. So I need to factor out 16. And that leaves me with x squared. So if I factor out 16 from here, that'll leave me with positive 10x. And again, I'm going to leave a little room for completing the square here. Equals 463. Oops, 463. Where's the, I wish, let me find the undo. Oh, well, just erase. 463. And then I want to have 2 blanks for where I complete the square. And so I'm going to have to erase all this. Hang on. I'm not real good at this lasso delete, but I'm going to try. That's not as bad as usual for me. Just one more. Why won't you go away? There. Okay. Add something to both sides to complete. Well, I'm being a little presumptuous when I put a plus there. Actually, let me just put 2 blanks here. Whatever I do to complete the square on the left side of the equation here, I have to balance it on the right side. So let me think about this. Completing the square in the y terms here. So the way you figure out how much to add to complete the square right here is you take this coefficient, so in this case -6, divide it by 2, and then square it. So that's -3 squared, so I should add 9 to complete the square here. Same sort of thing here, so take this coefficient, which is 10, divide it by 2, and then square it. That's the magic number that's going to complete the square. So in this case, that's 5 squared, so I'm going to add 25. Now here's the part where you have to be real careful. And I'm going to erase this stuff so I have some room. When you insert the +9 here, we're not actually adding 9, we're adding 9 inside the parentheses is actually resulting in adding 81. Because what we're really adding is 9 times 9. This is actually a +81 to the left side of the equation. When you slip a 9 inside this parentheses, that is a 9 in front. So if I'm going to balance it, I need +81 on the right side here. And so similar thing with the x terms here. When I add 25, that's not really a +25. So we need to think about, okay, well, so what is it really? Let's see. So there's a -16 out front, and then we slip the 25 inside. So this is -16 times 25. That's what we actually added when we stuck the 25 in here. So -16 times 25, that's -400. And so if we're going to balance it, we need -400 over here on the right side. So whatever you put in the parentheses, you have to multiply it by that number out front to figure out what you have really added to the left side and make sure it's the same quantity on the right side. All right, so if I clean this up, this is 9 times y minus, if you factor this, y squared minus 6y plus 9, 2 numbers that multiply to give you +9 and add up to -6. That's -3 times -3. So this is y minus 3 squared. There's your perfect square. Same thing here, x squared plus 10x plus 25, that factors as x plus 5 times x plus 5. So x plus 5 squared. Equals, when we combine everything over here, well, 463 minus 400, that's 63, plus 81, that's 144. All right, so now we're looking at this equation. Now, one other thing about standard form for the equation of a hyperbola, it should have a 1 over here on the right side. So we need to turn that 144 into a 1. So we should divide both sides by 144. So I'm going to divide on the left side of this equation by 144. So divide each term here. Now we can reduce that. So when you cancel the 9, that will leave 16 in the denominator here. If you divide the top and bottom by 9, you'll end up with y minus 3 squared over 16. Divide top and bottom here by 16, and you'll have x plus 5 squared over 9 equals 1 here. Okay, so there's the standard form for the hyperbola. And from that standard form, we can determine that this hyperbola is centered at, so to get the x coordinate, we look here. X coordinate for the center is -5. The y coordinate is +3. That's your k is 3. Always get the x coordinate with the x expression, y coordinate with the y expression. Whether it comes first or last doesn't matter. Now the actual graph of this thing, and I'm wondering if I have room. I'm going to get rid of a bunch of this over here. Clear some space. I don't need this either. Okay. Set up some axes here. Okay. So this is a hyperbola centered at -5, 3. So 1, 2, 3, 4, 5, 3. 1, 2, 3. There's the center. Now to graph this hyperbola, first we draw that box around the center. So because you have, let me focus on the x expression for a second. Because we have 9 in the denominator under the x expression, so that's 3 squared. So I move horizontally 3 units in both directions. So 3 units to the right. Was it 1, 2, 3 here? 3 units to the left. 1, 2, 3. Okay, there's 2 sides of the box. And vertically, so I look below the y expression, I see 4 squared. So I'm going to go up 4 and down 4 from the center. So 1, 2, 3, 4. And then 1, 2, 3, 4. Okay, and I'm going to use a lighter color for this. So here's that box that I was talking about that we draw around the center. And again, you get the dimensions for this box looking at the denominators below your x expression and your y expression. Now, the thing that I started out talking about, notice that the y term is positive. The y squared is positive, which means the hyperbola is going to be oriented vertically. So the actual vertices, that question about vertices, the actual vertices for this hyperbola are here and here. The actual hyperbola is going to open up off of those 2 points. These x points on either side of the center, those are just used to determine how wide or narrow the hyperbola is. And the way that doesn't really work here, I'm going to use the gray marker. So if I draw the diagonals of this box, like I said, that's what determines how wide or narrow the actual hyperbola should be. And then I'll graph this in red. So the vertices, because the y term is positive, the vertices are oriented vertically above and below the center. And then now you just do the best you can. We're just looking for a sketch here. So you follow those diagonals that we've just drawn from the box in drawing these parabolas. And there's the graph.